Hi, welcome back. Out of 6 steps, we have completed first 2 steps, that is inputting engineering data and second creating a geometric model. Now next step is to dividing a geometric model into element and nodes and doing a meshing techniques. So now what's meshing is and what's concept behind it, let's discuss that first. The process that ANSYS Workbench Mechanical solves a problem can be viewed as 2 major steps. First is problems governing equation creation, and second, solving those equations. The problem domain, or we can say our CAD model, is usually so complex or intricate that it almost impossible to establish governing equation directly from that 3D model. So how the ANSYS do it? ANSYS basically uses one method, numerical method, that is FEM. So what's FEM and what's meaning of FEM? So meaning of FEM is hidden in its words itself. The basic theme is to make the calculation at only limited number of points, a finite number of points, and then interpolate the result to full problem domain or our full CAD model. That may be surface or volume, or in our case we have a line bodies. So let me make it little simple. Consider a problem domain like this. So we have a continuous objects, and this continuous object has a infinite number of points, right? So we have so many tiny number of points in this object. So infinite number of points, it means that infinite degrees of freedom, right? Because each point or each object in space has a 6 degree of freedom. So 6 into infinity becomes infinity degrees of freedom. And it is just not possible to solve the problems in this infinite format. So what's the solution then? So what ANSYS does is to divide this infinite degrees of freedom domain into small pieces. So that is called as meshing. So in the meshing, or in a finite element analysis method, reduces the degrees of freedom from infinite to finite with the help of meshing. Okay, so let's divide this domain into 4 number of pieces. So 4 number of pieces will have 8 nodes. So number of nodes are 8. Degrees of freedom per node, let's assume, is 6. So total equation which we have to solve is 6 degree of freedom into 8 nodes, that's 48. So to solve 48 number of governing equation. So we've reduced our governing equation solving from infinite to 48. So that's what a finite idea is, finite number 48. Okay, so a central idea in finite element method is to divide the full domain into many geometrical known simpler pieces like this, which are called elements. So the small pieces is known as finite element, and these elements are connected by nodes with each other. So these are the nodes. So the governing equation for each element can be easily established, and the system of equation of all elements will be solved simultaneously. Okay, so dividing a CAD model into element is meshing, and the collection of element is called as a finite element. So there are so many elements and known number of elements, therefore they are finite elements. So in the next video we are going to see how to do meshing and do the further steps.